mode.
Good afternoon, everyone, and welcome to the YANGTime webinar. Sorry we're getting started a little bit late today, but we have Joe Register from the Auto Care Association and talking about emerging vehicle technologies, so I am going to hand it over to him. Joe, we're ready when you are.
Okay, thank you, Katie. And welcome to everyone. Good afternoon. We have a kind of a background on emerging vehicle technologies today, and you may have heard a number of previous webinars or done some of your own research regarding telematics, which is probably the best well-known of the technologies that are currently emerging in the marketplace. But hopefully what we're going to do is fill in a few of the gaps for you and maybe help you understand how these technologies kind of fit into the broadest picture. I'm going to start out with something I don't think is new or different for anyone that's on the line, which is there is something called Right to Repair, and this coalition was formed many years ago. And it's probably one of the most important pieces of legislation that the aftermarket has been able to bring to the general automotive aftermarket. And it has a lot of support, and a lot of folks are very, very aware of the benefits, but you may not be. And so this is just a recap of why Right to Repair was important. Really, for the first time ever, the aftermarket has an equal footing with new car manufacturers in order to be able to get the same information and have tools available to repair cars in the marketplace. That's guaranteed through this legislation, but some of you who maybe have arrived on the scene a bit later may be wondering, why do we even need some right to repair legislation? What is it about the vehicle itself and the way that it's manufactured that puts us in a position of not being able to repair it as we had in the past? Well, just in a very casual way, we're going to talk a little bit about how cars have evolved. This is really a very simple diagram that shows that when vehicles first were common in what we call modern vehicles, I guess. This is a commonplace electrical system. This shows the spark plugs and distributor cap. There was points, plugs, and condensers, which many of you may not have ever seen. And it was a very, very simple kind of design. The problem is that as more and more vehicles got on the road and there were really no controls in the way that the car's combustion operated as it was driven on a daily basis, this is what happened. This is a picture of Los Angeles in the 70s, and this is the result of vehicles that really weren't monitored for their exhaust emissions. It got to be such a bad problem, especially out in California, but in other cities as well. Legislation on a local level started appearing. Probably the most prominent being CARB, which was really started out in the California Air Resources Board, that was championing different types of approaches to reducing these emissions from vehicles, because the vehicle was targeted as being the greatest polluter and the greatest contributor of this. So vehicle manufacturers went about improving their performance by introducing a number of new technologies. One was catalytic converters. Another was a way that the vehicle was actually, its operation was actually controlled over time, and which was allowing a lot more granular governance of the emissions than those old points, plugs, and condenser systems would allow. There's an example of a distributorless ignition. So in contrast to what I was showing you earlier, this really doesn't have a distributor like the older system. You can see that there's been a computer that's been introduced, though, and a number of other sensor inputs that provide information about measuring the amount of oxygen that the vehicle is taking in, the amount of emissions it's putting out, and so forth. So this was a very important change in the way that cars needed to be manufactured. In the advent of these, really, I think probably the first diagnostic link that came on the scene was GM's ALDL. And it's important to understand that as these manufacturers were putting in these diagnostic ports into vehicles, there was really no consistency between them. Everyone had their own ideas about how they wanted to test their vehicles, and really this port actually came on the scene as a way for GM to be able to test the vehicles as they rolled off the assembly line. And then engineers are creative folks, and they started thinking about how they could repurpose this in order to be able to let repair shops be able to get this information as well. Their focus, of course, being on the franchise dealer. So what we really had is a picture of the overall landscape is that you had millions and millions of vehicles, and different kinds of vehicles, different types of ignition systems and fuel systems and so forth. And it really resulted in all these different kinds of connectors. So the industry really started to consolidate around a particular port design, and it's referred to as the OBD2 port, or the diagnostic port. And you can see there's a number of different standards around that, but they all kind of look like the gray connector that's in on the right side of those standards that are shown. What this really did is allow the emergence of a diagnostic business in the aftermarket. So it really potentiated the OBD tool industry, all the handheld scan devices, and I'm sure that probably the majority of you are aware of those devices. And it really gave birth to this entire aftermarket diagnostic business. So it's important to note that prior to that, really, there was nothing more than some electronic metering. I mean, you had dwell meters and RPM and all the rest, but really there wasn't any way to have the machine start to tell you what its problems were, and that was in the form of problem IDs and diagnostic trouble codes and so forth. Well, these ports evolved and they continued to be standardized, and over time, there was all kinds of opportunities that were realized by connecting to this port that really weren't intended at the onset. In other words, that port was really being provided to the public and documented to be able to get emission information, state inspections and all the rest. But we're a creative bunch, and with this port and having it available, people started sampling data that was coming out of this port, and pretty soon they started realizing that there was a lot more data than the data that was provisioned under legislation. So you could make use of that data if you could either find out what it was directly from the manufacturer or start reverse engineering. So you could see what problems were being demonstrated. You could start seeing what kind of information was flowing and start making determinations about what was actually happening in the engine just based on the output that you're receiving from this port. A whole bunch of new different devices have come out where you can actually monitor the internal engine's operation even during operation of the vehicle. The vast majority of them will have what's called a dongle connector here, which is, as you can see, is just this yellow device that's plugged into the OBD2 port. Now, it may actually be physically connected to a device that you're using to measure the information. It may actually be wireless in the form of Bluetooth and so forth. These connections have led to an entire marketplace of different kinds of smartphone applications or dedicated devices, all kind of referred to as nomadic devices because they aren't actually built into the vehicle at all. The problem is, of course, that an unsecure OBD2 port can lead to trouble, and we're not too concerned right now about the ones that are physically connected because hopefully you're the person that put the physical connection in place, but much more concerned about the wireless connections. We go to a lot of trouble with most of our wireless communications to make sure that they are very, very secure. So there's a tremendous amount of energy and time put into making sure that we have the correct kind of identity and access management. Identity meaning we know who you are, and that then from a standpoint of access that you're given the right level of access for the particular kinds of activities that you need to perform. Unfortunately, Bluetooth is inherently unsecure as a network, and so it's pretty straightforward in being able to hijack the signal and be able to get into the access point to the OBD2. And that, of course, is very problematic. I think most of you have probably heard about a Jeep that was hacked, and somebody was able to access remotely. Now it was staged. I mean, from a standpoint that people knew that they were going to attempt an intrusion, but the result was very real. This is, the brakes were disabled and the car was steered into a ditch, and I think this started to really raise awareness at a very broad level that you could actually take over a vehicle through these OBD2 connections. So as awareness grows, concern continues to grow, and everyone really now is focused on finding ways to secure the vehicle networks. I mean, the bottom line, the objective on this is to protect vehicle networks from cyber attacks. Now there's, as we said, there's a couple of alternatives in how you connect. You can connect wirelessly or you can connect physically to the OBD2 port. But regardless of the method that's being used, we should still have the same ability to be able to identify the person that is accessing it and the kinds of information that they should have access to. Now, in many cases like this, when it takes a while, and just as we did with the OBD2 port initially and all the legislation around emissions and so forth, this has taken a bit of time to rise to the surface. And so in the absence of any strong federal mandate, the states themselves are taking action. So this is weeks old now. Michigan has proposed a cybersecurity bill that probably takes the most onerous tack to trying to control this kind of activity. They're actually talking about life imprisonment for hacking into a vehicle and willfully causing damage or taking control of it and so forth. So I don't think there's any doubt in the fact that this security needs to be in place. The vehicle needs to be protected. Some folks may put various types of dongle devices on their vehicles for different purposes, and there can only be one at a time, but you may change them from time to time. An insurance company may incent you to record information that they can reference so you can get the best rates. You may actually want to record the information yourself, or maybe a parent wants to see what one of their younger drivers in the family are doing when they aren't under scrutiny. And as a result, that information gets recorded and all the rest. But again, depending on how it's accessed, it can open the door to unsecured and unwanted access. So there really are two different visions for securing vehicle access going forward, and this isn't widely known, I don't believe. But vehicle manufacturers have been working very hard to come up with a solution because they're under the gun. Probably most commonly everyone thinks of the vehicle manufacturer as being the responsible party for securing the vehicle. But there's also different ways in order to be able to do that. And so there's really this extended vehicle concept, which many of the vehicle manufacturers are supporting. And then there's an alternative secure vehicle interface, and we're going to talk about those just briefly so that you have a better idea of the limitations and some concerns that at least one of these designs can raise to the aftermarket. So this is an illustration of the extended vehicle interface, and it's nice and simple. Interestingly enough, this comes right from the working group in ISO, which is the International Standards Organization, that these vehicle manufacturers are working with. And you can see here that what they've really done is they've wrappered the entire vehicle, and that's what the circle is, the ellipse around the vehicle. And in the middle, between the vehicle and the interfaces, is actually a vehicle manufacturer server. So what they've really done is they have put their own infrastructure and their own server bank and cloud-based in between the vehicle networks themselves and any external interface to the vehicle. They are, you know, very clear about the fact that they do intend to be able to redistribute the data, but that would be under their control. They would select certain service providers that you see to the right. These would be third parties that would be designated, and those of us who are in the bottom, and you can see this information flowing to a nomadic device down there, whether you're a repair shop or whether you are a consumer with a vehicle, the very best you can hope for is to be able to get information from this service provider, and they would be the ones in control of the rates for that and what would be provided. So there's two levels now of shielding of this data. The first is from the vehicle manufacturer themselves, and the second one is from the service provider. Now, just in case it may not be too clear about this, because it shows a web service interface over here, they provided yet another drawing, and this one there's no ambiguity about whether the OBD2 port, that physical port, is included in their vision. You can see that at the bottom. So really any information flowing out from the vehicle, as well as in, and obviously in is of the greatest concern because you certainly don't want someone to be remotely accessing your vehicle while it's in operation without your knowledge. The other side of the coin is all information coming out, and that can be quite useful for a number of different things. You know, the smart apps that are out there and all the information that people want to collect about vehicles. And we'll get into some of that in a bit. But this is certainly the most onerous technique as far as protecting the vehicle in light of how the aftermarket is going to need access to this data. And in fact, here's a few concerns that you may want to be aware of. Under this extended vehicle design, the vehicle manufacturers have the opportunity to be able to be very restrictive about the sharing of information. And if you look at it from a light of maybe what potential exists for that control, information, then that's the information that the aftermarket can also get access to. Now, it's not free, and there's a nice, a really capable group of technologists that form up the Equipment and Tool Institute, the ETI, which is really the primary negotiator of this information on behalf of the aftermarket. So they get it from the vehicle manufacturers, negotiate that, and then that information goes into scan tools and so forth that we all use. That is under pressure with this design because we suspect that the vehicle manufacturer can meet the letter of the law by simply forcing franchise dealers to take advanced diagnostics from their cloud network in place of the actual data that is being received today. So in other words, instead of directly getting the diagnostic information as we do through the OBD2 port today from the vehicle, instead what we would get is the actual diagnosis from the vehicle manufacturer. Replace this part or replace that part. And as long as the franchise dealer was, you know, either willing or encouraged to live with that, it might very well be the only way that the aftermarket would still be able to get diagnostic information from the vehicle. So this is a very important piece because we have a lot of very well-trained and very capable diagnosticians in the aftermarket. And I think it's safe to say that the vehicle manufacturers and their franchise dealers typically get pretty disinterested in the vehicle once it's out of warranty. Now, I think that's, as that happens, people gravitate to the aftermarket, and there's also cost factors and a number of other pieces here as well. But it's really maybe not so well known that we have some of the very best diagnosticians in the aftermarket because they have to work across different brands of vehicles with different problems and all the rest. And if you have a 7 or 8 year old car, you're very grateful to people who have that expertise and capability. The franchise dealers typically don't see vehicles out through warranty, and so if you did take a car in, then they would probably struggle a bit to try to figure out what the problem was, and especially if you brought in another brand than the brand that they actually sell. So this whole business of the aftermarket diagnostics and so forth, we feel may very well be under threat with the extended vehicle design. And so as time goes on and vehicle manufacturers want to continue securing vehicles and providing their own services, because the benefits of the information that flows from the vehicle isn't lost on the vehicle manufacturer. I mean, they continue to, behind the scenes, do their own development and their own ways of being able to bring this information to the consumer, and typically the consumer pays for that as additional add-ons in the vehicle. So you may be familiar with Ford Smart or OnStar or BMW telematics. These are all kind of what's going on right now while this extended vehicle discussion and future state is being discussed and deliberated. Everyone's kind of out there in the wild doing their own thing for the present. And this, of course, makes, if you invest in learning a particular kind of approach, it's going to be less comfortable for you to move from brand to brand as time goes on, just because of the difference in interfaces and the way it behaves. So these devices, in many cases, are not dependent on the OBD2 port at all, but the vehicle manufacturer has different proprietary network connections to make these operate. So there is no leveling of the playing field possible with this kind of a design, and that's concerning as well. So the aftermarket has been asked by the vehicle manufacturers over the last couple of years as we've been raising these concerns and talking about the data. Okay, well, first of all, we think you need to come it's actually provisioned in the vehicle itself. It's not part of a cloud-based strategy. It is remote. Any information flowing in or out of the vehicle would come through a firewall. Now, it doesn't matter whether that's a physical port or whether that's a wireless port. It would still be provisioned through, the access would be provisioned through this firewall. We'd use the same kind of identity and access best practices that are in place for the most secure kinds of transactions that are currently in place for financial, for moving large amounts of money, and for security for military and all the rest. So there's ways to harden this to whatever degree that is required. The great thing about this, I believe, is that the SVI is not an aftermarket only solution. It is equally usable by the franchise dealer as it is by the aftermarket. And really, it's content agnostic by design, and by that I mean we haven't picked or chosen a particular number of pieces of information at all. What we've said is there's going to be a consistent way in order to be able to get data It's going to actually be a set of labels that the vehicle manufacturers will all map to. What actually comes through those pins, what actually comes out as far as data, is a kind of a second discussion, because really what we're talking about right now is the connection, and then we'll probably get into a much more protracted dialogue about the actual kinds of data that need to flow. So this is the first step, but it's a very important first step. The second thing that we were asked, besides a technical solution, and I do want to just also stress the fact that this isn't something that we've come up with in the aftermarket. This is also an ISO specification created by a slightly different group than the extended vehicle, but still very much in harmony with the ISO, SAE, IEEE standards that are already in place. So this is not something we've gone off or a few engineers have been working on. This is something that's had a fair amount of scrutiny. So together in the aftermarket, we have had a discussion about the two designs, and we feel as a group of aftermarket associations, and this includes the ones that you see on the right, and it includes also AAA, which has a tremendous amount of stake in this as well. And we've all decided that this secure vehicle interface is the right option going forward for standardizing and securing vehicle access in the future. So this is kind of the future state, and I think probably the best way to illustrate the value in this is to take a look. This is just a kind of a different take on the original diagram that we were looking at. So you had the divergence and consolidation again. So now you have all those different kinds of solutions, the GM OnStar, the Ford Smart, the BMW Telematics, all those pieces. And it's really, you know, all the different kinds of ways that vehicle manufacturers have thought about provisioning access to the consumers. And now on the scene has arrived, you know, automated driving assistance systems and truck platooning and et cetera. So these are all out there too in the environment and need to be addressed. So really, ideally, you'd have one solution that would address the needs for everyone, all these stakeholders, whether it's ITS stakeholders or whether it's consumers themselves or repair shops, which include franchise dealers. And that's really what we see this, you know, OBD2 migration to this secure vehicle interface. So really, what you see here is that you still have this port. And you also have wireless connections, but it's all still coming directly through the firewall. This is in this slide. The implementation then, you know, enables this worldwide industry of you know, roadside assistance and remote assistance and being able to do remote diagnostics and all the rest. That's the payoff for doing it this way. So instead of having these proprietary methods of communicating to the consumer when there's a problem and making their own appointments with their franchise dealers and everything, all of this would be an open standard set that the aftermarket and the broader you know, marketplace, whether it's Apple or Google or whomever, will very likely find opportunities to be able to provide some great services in the future. And while we bring up ITS, I guess I do want to underscore that they're another important stakeholder in this. They're not particularly well known yet, although I imagine that this group is pretty aware of ITS. As you drive along and you look up many cases, you'll see cameras along the roadway, and that's all part of the ITS infrastructure that's being put in place. In its broadest sense, ITS really is about all kinds of transportation, including planes, trains, and automobiles, railways, and all the rest. And it's the larger picture of the government looking at how to be able to get a handle on all the various types of transportation that are out there. Now, we're obviously not very concerned about boats, ships, harbors, and air transport, but we are concerned about the connected vehicle. And this is something that is becoming more and more obvious and important. You've been hearing probably about different types of alternatives to being able to have the vehicle drive itself. This automated capability is going to be dependent upon getting information real time about the vehicles that are on the road, about the infrastructure, just around the environment. Different types of transports that may be interfering with roadway systems, rail cars, and etc. So with being able to get the information real time on all these various transport methods allows us to be able to coordinate the traffic management in these large metropolitan areas much more efficiently and effectively. I mean, that helps all the way down to lessening congestion and helping people pick maybe public transportation in lieu of private at different times depending on flow. One of the really big advantages of this, I think we're all familiar with the fact that there's radar in a lot of cars now, but radar is limited to line of sight. So if you can't see it with your eyes, then the radar can't see it either. ITS connections actually provide ways to be able to gather information through the network, communicate that to the vehicle, and allow the vehicle to react to its environment much more quickly and much more consistently than some of the devices that have been retrofitted to vehicles today. At the end of all this, what you get is a hybrid that many people are looking at having a combination of both the vehicle's internal architecture and devices along with nomadic devices. And so you have a smartphone or a tablet device that you may take with you when you leave the vehicle. It has important information about the vehicle as well and may actually be able to operate as an extension of the vehicle's dash down the road, providing not only infotainment but also information about the driver and the driver's condition and all the rest. So this vision of these hybrid kinds of vehicle dashes in the future, there's a lot of folks, especially I was talking to some of the vehicle manufacturers in Asia, and they actually envision the smartphone becoming an integrated part of the dash in their vehicles in the near future. You actually will take this out and the car is essentially inoperable without having some kind of communications. And of course there's issues about, well, what happens if you drop your phone or somebody steals it or whatever. But they believe that this is an important part of the personalization that can go from vehicle to vehicle down the road. So interesting concept at least. At this point, we've talked a lot about the enablement of the networking and being able to extend the network from the vehicle outward, be able to connect to the vehicle, even in operation, the stakeholders that are involved in that. But there's a much bigger conversation that we know we need to have, and it's one that we're avoiding at this particular point in time simply because you have to have a way to access information before you can really talk about the information that you want to access. But the reality is, it's really about the data, and it's long-term implications to business. And again, as I said, this is not lost on Google or Apple. It's certainly not lost on the vehicle manufacturers. They're collecting data by the ton already. So what is this data? Vehicle data actually can be broken down pretty easily into two different categories. As I said before, the secure vehicle interface is content agnostic, so it doesn't really pick or choose between the kinds of data. That can be provisioned from a standpoint of identity and all of the access layers, which you're allowed to be able to get to. But the interface itself, it's immaterial. It doesn't matter what data is flowing through it. But the two categories are very, very different in information. Vehicle health and ITS requirements are really all about the health of the vehicle, whether there's diagnostic trouble codes, problem IDs, and so forth that are being transmitted. We would hopefully still get access to that information at that detailed level. And even better, the secure vehicle interface provisions for a consistent way that that's referenced across manufacturers. So that's a real boon to the folks like ETI and scan tool vendors and so forth, because instead of having to try to come up with a particular proprietary term for every vehicle manufacturer and vehicle, they would be consistent across all brands. So that's a real plus with the SVI design as well. ITS device communication is really just as important, and this is all the near real-time data for speed and geolocation, all of the information that's going to be necessary to be able to judge proximity between vehicles, speed, if it's a potential collision or whatever. All very important, all most important if it's near real time. The second category is much more controversial. This is all the driver profile and behavior, and depending on how you drive and depending on how concerned you are about your privacy, this may concern you more or less. Information about the seat positions in the vehicle, so with that and the weight, they can certainly tell who was driving at a particular time. Parking locations, some vehicle manufacturers store up to the last 100 parking spaces. Emergency stops, so for instance, if you're someone who accelerates rapidly and then you stop rapidly, so it actually tightens the seatbelt, they record a number of those incidences. The speed and gear and the maximum RPM, and it isn't lost on anyone that this also includes geolocation information. So let's say that you happen to be at a very high rev limit and you're going very quickly in a location where you shouldn't be. All that information certainly has the potential to be recorded. There is a counterpart to AAA in Europe, and that group, the ADAC, had actually done an investigation of several vehicle manufacturers in the EU, and they found this and a lot more information was not only being gathered by the vehicle manufacturers but retained and resold. And so they've gotten quite formal about their objections and actually have sat down with the vehicle manufacturers in the EU with counsel on both sides to start talking about how this should be managed in the future. But I do want to underscore the fact that in the automotive aftermarket and in the conversations that we're having, we're really focused on the vehicle health and diagnostic data. We're not interested about collecting or acquiring and persisting behavioral data. So we're really focused on information that is going to help us repair cars efficiently and correctly the first time, and provide that a very important, especially post-warranty service that consumers really depend on us to provide almost exclusively. So just to go through real quickly here the ways in which telematic data can impact our business. I'm sure that many of these have come to your mind already, or you may have read some articles about this. Manufacturers can actually get some agnostic part fault and early wear out information. So it's relatively easy for a manufacturer to understand which of their own parts may be failing, but to be able to get information about the problem with the part and be able to collect that and be able to measure it, immaterial about which particular manufacturer it was. So this gives some indication that maybe the design at a very fundamental level is an issue for some vehicles. Also they can tell the environmental, if there's consistent environmental impacts to these parts, in other words, when they fail and why they fail, particular temperatures, particular altitudes, or whatever it may happen to be. This can help them really with being able to improve their designs, probably even in advance of the vehicle manufacturer in some cases, because the vehicle manufacturer is only going to look through a single brand, whereas an aftermarket manufacturer will be able to look across brands. Retailers and distributors, it's a lot about putting the right part in the right place, and so We use vehicle population data for that today, and this gives another layer of refinement to be able to add to the registration information, the actual operational information. So again, they can find out where these cars are failing in the location, push stock to the closest particular group of related data incidents, and optimize their geographic stock locations. And I don't think there's any doubt that the group that is most likely to get the greatest benefit is the service provider themselves. And all different kinds of potential capabilities can be envisioned between predictive maintenance, remote diagnostics, prognostics. In the past, well, still currently, but certainly over the years we've come to rely on scheduled maintenance to keep a car operational and to try to avoid repairs and instead perform maintenance operations. And that's based on a particular mileage or a particular age. And it's really very, very broad in the way that it's designed. A lot of times parts will get replaced before they need to be. You're not actually getting any information to make those decisions. You're just using a maintenance schedule that the manufacturer has ordained based on their design expertise. This allows you to be able to actually refine those much further and be able to say, look, we're getting information from the vehicle that this part's failing early, so it's constantly having to be, it's throwing trouble codes, there's issues around, we're getting warnings. This part's going to fail much sooner than it was originally expected. So with that kind of information, you can start and the driver comes in and has that maintenance performed before there's an actual failure on the road and they're stranded. I think another piece of this is, and this is certainly not lost on the vehicle manufacturer, they're making deals today with a lot of parts providers to be able to provide parts to the dealer at the right time. One of the things here is the real ideal situation of an ad hoc service. So let's say, for instance, if you have a GM vehicle and there's a collection of information from the vehicle about a particular part that seems to be failing, and there can actually be an offer of having a appointment be scheduled for you with the franchise dealer and the rest, and same with Ford Smart. We can also do that in the aftermarket if we get access to the same information, and through electronic parts ordering and being able to go through and use information provided from folks like Mitchell and ALLDATA, Formix, and et cetera, we can make these determinations as well, and even do it across brands, and be able to order parts and have them there. What kind of business benefits there are from getting access to vehicle data, and why that's important to the aftermarket going forward. So this is the end, Katie, of the prepared presentation. So if anyone has any questions, I'd be more than happy to answer them, and I appreciate the time, and I will turn this back over to you.
Sure. So I forgot to say at the beginning, be sure to type in your questions in the chat box. So we have one so far. So how about the visual base OBD2? Would that make a change in the industry?
Yeah, I think so. I mean, from a standpoint of what the designs are currently that are being shared, the design details that are being shared with us, I mean, we don't have enough detail right now, and especially we don't have enough detail about how we extract the information. So, I mean, at this particular point in time, I'm really not as up to speed on that particular piece, but I would say that it's bound to have implications, yes.
And then we're getting a few more questions in.
Sure.
So is there a fear that government will want to control the data?
Yeah, of course. Of course. And, part of what we're doing is sitting down with, the folks in Capitol Hill and talking to them about the issue. And there are lots of interested parties, and that includes, people who are concerned about security such as Homeland. And they want to be able to get information about maybe a dangerous payload in a truck and be able to divert it, and it's understandable. However, it's the retention of this data, and we already know that the government has very large clearinghouses for data, being able to get it even in telephone transmissions and so forth, and collecting it and being able to analyze it over time. That same capability would certainly exist in this case as well, whether it comes from the manufacturer or whether it comes from a secure vehicle interface. But yes, absolutely, I mean, that potential exists.
Okay. Many service providers are very wary of the notion of remote diagnosis using
Right.
the OBD2 port. What's your comment on that now and in the future?
Right. So, I mean, I think that a lot of times what you have to do is kind of go to school on a particular vehicle brand to really feel comfortable about the information that's provided. It isn't consistent today across brands, and so depending on the vehicle it is that you're repairing, the information that you get may not be consistent. In other words, there may be holes in the data. You may get this collection of data from one brand and a different collection of data from another brand, or very little information at all. You keep in mind that the amount of information that flows through an OBD is much, much greater than what's provisioned under legislation. So, getting that information ahead of time and being able to collect it and make sense of it, there's really two levels. One is getting access to it. The second level is having some information provider who has actually gone through the process of mapping these trouble codes and PIDs and so forth to actual practical diagnostics. And so if the greater your access to that kind of information, and not just depending on the analysis of a diagnostician in shop, so much the better. But I think that as time goes on, certainly remote diagnostics are going to be a greater and greater piece of this, largely driven, to be interestingly enough, by the fleet folks primarily. They've been really collecting this data probably the longest, and they've been most interested in being able to keep trucks on the road. Obviously, that's a commercial operation for them. So they've done a great job in being able to collect this information and make sense out of it over time. But I don't think there's any doubt that this particular discipline of remote diagnostics is going to improve very rapidly over the next 10 years.
And then the final question that's come through, will the OBD2 port eventually fall off and just not have a port at all and become all Bluetooth or something?
Sure. Yeah. Well, I mean, that certainly has been threatened by several vehicle manufacturers. I think Volkswagen has probably been the loudest about the fact that they were considering designs to put the OBD2 port in the actual door jamb, so that you couldn't connect anything to it during operation. There certainly is a lot of dialogue right now about the disappearance of the OBD2 port, and we just received some communication from the DOT that based on some concerns being raised from Energy and Commerce Committee in the House, that they are going to ask our input and a number of other people input as to the need for the OBD2 port going forward, how it can best be secured, and so forth. So this is all part of why this secure vehicle interface is an important design and why we're trying to raise some awareness of it now. But we'd certainly like to see the port continue until everyone is much more comfortable getting information wirelessly.
Okay, great. Well, Joe, thank you so much for your time today. It was a really informative webinar, and we appreciate all you're doing for the industry. So save the date for our next webinar, October
Did I lose you,
6th.
Katie? Or
Oh. Sorry about
oh,
that. Sorry, I'm
that's
having some
okay.
audio
Not a
issues.
problem.
So save the date for our next webinar, October 6th at 3 p.m. Eastern Time, Ahead of the Curve with Jesse Finnerty, all about Apex and what you need to know. Information will be going out on that later in the next couple of weeks. So again, thank you, Joe, and everyone have a great day, and we'll see you next time.
Thanks a lot.